Okay, so we want to look at drawing this rectangle and oval pattern down the diagonal. So we're going to start with a 600 by 400 window. I'm going to choose strategically a rectangle that's 30 by 20. So the reason I'm doing that is so that, and I'm deciding those values so that, you know, how many copies are we going to need to fill 600 by 400 is going to be 20 exactly in both directions. So 20 copies of this guide down the diagonal. Will one start in the upper left corner at 0, 0. And the last one will be down here at whatever that is. I guess it'd be 580, 570, 380. But we're not going to need to know that value. So rather than trying to draw this through a loop initially, it makes sense to sort of start by just drawing the first one and make sure you can get it to work. So we'll do that first, and then we'll come back and loop it down the diagonal. So we'll do a new, I'm in chapter 3G. I'm going to do a new Java class, or new class. Let's call it diagonals. Again, classes are capitalized. Diagonals 1. I'm going to do 2 of these. So we'll start with the first one here. My block commenting at the top that everyone should have on their code. You put your name, the class, the date, and then a description of the program that you're coding. So this program will use loops. I'm going to say loops and methods. You know, normally we wouldn't say either of those things. I'm saying loops and methods so that you understand what the point of the argument, what the point of the program is for our learning. You would normally just say what it's going to do. This program will, so I could leave out the use loops. I could really do it like this. This program will, that use loops and methods part is for us as a class. Use loops and methods to draw a series of rectangles, ovals down the diagonal. Okay, so like I said, we're going to initially just draw one. So to do that, we need to import java.awt, and I'll just import everything from there. And we'll start in main here. We need a graphing panel. Let's call it P. Oh, sorry, drawing panel. P, new drawing panel. Just learning the syntax here. Then we need a graphics object to be able to draw on that drawing. Oh, we need to, let's tell it how big we want that panel to be, 600 by 400. Then we need a graphics object to be able to draw in that panel. So graphics G, and this is a method of the panel. So p.getGraphics will generate a graphics object for us to draw in that panel. And then let's run it and make sure that, you know, iterative process, make sure we have our window that opens up. There it is. Perfect. And now I want to draw that rectangle in the upper left corner. So it's going to be draw rectangle starting at 0, 0. And I believe it's 30 pixels wide and 20 pixels deep. Oh, and I need to do g.draw, of course. Run it. Oh, it's tiny. That's okay. We're going to have 20 of those in the window, so it's fine. And then I want to put an oval inside that. So G dot fill oval. And again, if you have errors, syntax errors, whatever, just pause yourself and pause me. Again, it's 0, 0, 30, and 20. But I don't want it to be black. I want it to be green. So before we fill the oval, we need to change the color. So G dot set color. And I go color dot green. And I also noticed that the green is obscuring some of the boundary. So I might change the order on these two things so that so that it first draws, first draws the oval and then puts the black boundary around it. So I'll copy this rectangle out, cut it out, paste it in below. And if I do this, it'll be green, so I'm going to have to change the color again. Between. This will be good for when we do the loop anyways. Okay, somehow I automatically commented this out, which I didn't want to do. So we're drawing the oval, filling it, drawing a filled oval, and then we're drawing a rectangle around it. And you'll see now that box goes around the rectangle, the oval a little bit better. Okay, so we got our one. Now I want to think about, well, how am I going to go all the way down the diagonal here from this at the start all the way down to the bottom? So we're going to go back to pencil and paper, and this is something you have to figure out on paper, but there's 20 copies. So if we run a loop that runs 20 times, that will generate the 20 copies. So each time through the loop, we could look at sort of the value of I for the loop, the value of X, and the value of Y. So I could loop through X and Y, but I think it's easier to start off with looping through I. So if I is 0, X is 0, Y is 0. When I is 1, X will be 30 and Y will be 20. When I is 2, X is 60, Y is 40. So we can see from this little table that X is changing by 30 each time, and Y is changing by 20. So it's really the slope, but it's the change in the X values here. It's a little weird if you're thinking of slope as change in X over change in Y. That's a little different because each one would have slope, but I'll just call it the change in X and the change in Y because they both start at 0. So the y-intercepts here are 0. And then what we're changing each time here is X is increasing by 30, positive 30, and Y is increasing, not by 40, excuse me, by 20. Okay, so now it really is, you can think of this as X would equal, it's confusing. It is a linear relationship, but it's confusing that I'm using X and Y. My linear relationship is usually thought of as Y equals mx plus b. So this would be, if you were doing it, it would be X equals m times I plus b, but b is 0 and m is 30. So X equals 30 times I. And same thing for the Y value. Y would equal m times I plus another b. But again, that b is 0 and that m is 20. So we're going to jump back into Eclipse. And we're going to put this content in a loop. So I'm tab in, I'm going to say for integer I equals 0. I could do, I want 20 of them to run. So I want I to go up to 20. I want 20 rectangles. So I would actually only go up to 19. but I could say I is less than 20, or I could say less than or equal to 19. I think it makes more sense to say less than or equal to 19. Doesn't matter. And then I will increase by 1 each time. And each time I increases by 1, the X value in this code, so I'm going to copy that out. Actually, let's copy the whole thing out and paste the whole thing in here. So notice the indentation, it did it correctly for me because I'm inside these braces, so that might be a place where you have you know, errors. And then, so the X is starting at 0 and increasing by, let's go back real quickly, it's 30i plus 0. So that's this first thing here. This is now, I don't need a variable X. I could have one, but I can just use, just replace in here the X value, 30 times I, and then plus 0, so I don't need the plus. And then same thing for the Y, it's 20 times I plus 0. And again, it has a width of 30 and a height of 20, so that's the oval. And then really the same for arguments for drawing the rectangle. I'm just going to copy and paste them in there. The X value is 30 times I, the Y value is 20 times I. Notice the changing of the color. We first drawing a green oval, changing to black, drawing the rectangle. Going back into the loop, changing the color to green, drawing the oval, going to black, drawing the rectangle. Looping through. So at the end, what color would it be? It would be, if we were going to draw something else, it would be black. Just something to keep aware of. Or you could always draw something else and see what color it is. Ah, there we go. Cool. So I'm going to stop this video here, and then I'm going to come back and modify it so that we go up the diagonal in the other direction. Which we're going to do first by just kind of repeating what we just did, and then by using methods with a parameter that passes in the initial values for X and Y along with the increment. How much is either X or Y changing by? So we'll use parameters to take that same code and instead of having sort of the same code repeated twice, we'll use a method to capture that whole code in one fell swoop. I'll go back to the code in case you need it. If you want to pause here, get a good shot of the code.